Oh! Hey, here's a video of me doing my trig homework, because that's what I do at Disneyland. On the ride, got some time, I do my trig. All right, so I'm going to do the review, which is just like the test. Okay, I'm going to fly through it. Pause whenever you want. U plus V, just add them up. 6 plus 3, 6 plus 3, 9I. -2 and -2 is -4J. And the next one, 3I minus, sorry, U minus V. 6 minus 3 is 3. Be careful, -2 minus J. -2 minus -2. -2 plus 2. That's 0J. It is a vector, so you do have to put the I and the J. Remember, I and J is really just X and Y. That's all those are, you know. Okay, 6V and 8W. Careful, I changed the letters on you. 6 of these, let's see, that's 18. And 6 of these, I'm going to rewrite it, minus 12. Can we put the I and J in there? Plus 8 of these, that'd be 8I and 8J. So here's the first one, 6 times those, 8 times those. Now we can add them up. 18 plus 8, 26I, and -12 plus 8 is -4J. All right, next one. Hey, the magnitude kind of looks like absolute value of U. So here's U. So that's just the distance. If you were to think about it, you don't have to graph it. Remember, this means over 1, 2, 3, 4, 5, 6. 6 is like the X. Down 2. Down 2. Over and then. So the actual result vector is this guy. Yeah, that's over 6. Down 2. That's him. 6I minus 2J. The magnitude means how big is it? Like, what's the magnitude of the earthquake? How strong was it? How long is this? Just Pythagorean theorem. 6 squared and 2 squared. I know it's negative, but this negative will get squared out. So just do Pythagorean theorem. 6 squared is 36. 2 squared is 4. 36 plus 4. Don't forget the square root, because 40 would be too big. The square root of 40. And you can even break that down into, remember doing this, 4 times 10, because I know the square root of 4 is 2. 2 root 10. That's how I got 2 root 10. You could also put a decimal answer. The unit vector means, okay, let's take this vector, but you know, instead of going the entire distance, can you make him a unit? And a unit means length or magnitude of 1. So in other words, chop this guy off. Imagine you had some polar graph paper. Chop him off right here. Just kind of go, this real tiny, tiny baby vector. What would that vector be? Okay, so the rule is we're just going to take our answer to U, 6I minus 6I minus 2J. You're going to divide it shorter. How much shorter? Half as short? How much shorter is it? Remember the length was radical 40? So just divide it by radical 40, or maybe I should say divide it by 2 radical 10. But you can't leave it like that. You have to make it look like a vector. So split it. We've got this and this over 2 radical 10. So I would say 6 over 2 radical 10 I minus 2 over 2 radical 10 J. Ta-da! Wait a minute. Does that look simplified? No, we could actually do a little canceling. 6 over 2, 3. 3 over radical 10 I. And all these 2's cancel. Minus, I guess, 1 over radical 10 J. And there's my answer. Of course, you could say, do I have to get rid of the radicals in the bottom? Yeah, we could do that, but let's just leave it. Okay, and here it is with, I moved the radicals up. 3 radical 10 over 10, radical 10 over 10. Okay, dot product. Dot product, so you do AA plus BB. You times them. We're going to do U and V again. So go 6 times 3. Those are the A's. I know the AI, or the whole form of a vector is AI plus BJ. Okay, so AA, 6 times 3 is 18. Whoop. And then 2 times 2, -2 times -2 is positive 4. 18 plus 4, 22. Okay, the angle between U and V. This one's probably the most work. Remember, U's going some direction. Remember I said U went kind of went over 6 down 2 was like this. And if I said, well, where's V? V is over just 3 and down 2. It's kind of like that. And if I said, so what's the angle between these two vectors? So this one went way over and down 2. This one over a little bit and down 2. So what is this angle like right in here? What is that angle? So we got to use the rule. And the rule says, turn this over a little bit. It says cosine of theta. Remember to write the rule? U dot product V over magnitude of U times magnitude of V. I know letters U and V, they look kind of the same. It's kind of hard to see these in here. I'll put them in red. There's a U. There's a V. Okay, so we have to do dot product of U times V. Oh, we just did it, didn't we? 22. So we'll put that guy in there. So we got 22. And then we have to do the magnitude of U times the magnitude of V. Did we already? Oh, I got that. 2 radical 10. So we'll put that in. 2 radical 10. And I got to times that by the magnitude of V, which I haven't done. Where's V? Here's V. Let's do a little Pythagorean theorem on him. 3 squared plus 2 squared. I know there's a negative, but it's going to get squared out of there. 9 plus 4, 13. Radical 13. And so, remember, there's cosine here. Right here, cosine. Cosine of theta is this. So you for what angle has this number? Well, I got for what the heck number is this? Let me rewrite this number a little bit. 22 over 2 times that. Well, radicals like radicals. 130. Okay, let's put this in the calculator. What angle is this? And remember, what angle is that? That's not the angle, so this is where you have to go second cosine. Okay, so I get my calculator. What angle gives me? Why we got such a funny number here? So we go second cosine. Make sure you're in degrees. So let's see, 22 divided by this whole thing. Let me use a little parentheses here. 2 radical 130. Oops, I have to make that over here. Close it up, close it up. So I think I got it in there, 22 over 2 radical 130. And it says the angle is 15.255. Let's round it off to 15.3. So the angle is 15.3 degrees, which sounds reasonable because remember my little drawing? It didn't look like it was, really that far apart. So 15.3 degrees. So remember, you got to do, this is your rule, do the dot product times these. If you want to break this down to a decimal first, then punch it in like, what this decimal was? I ought to just change that decimal, then I'll just go second cosine. Make sure you do second, because you're trying to figure out what angle has this cosine, 15 degrees. And it's good to draw it just to make sure it sounds reasonable. Okay, here's a little bit of pilot school. Imagine, draw A plus B plus C and the resultant vector. That means the result. So pretend this is you. You went on a hike with this vector. Remember, vector has a direction and a magnitude. See, this guy's longer. So you're going to go exactly like this. Do it as exactly as you can. Like that. So pretend you're walking along. You go like that. And then now you're going to change course and go this way. Like you're in a sailboat and you're going this way. Oh, let's go this way now. It's a little bit not quite the same. It's a little bit different angle. More like this. Get it exactly the same. And the length. You went really far. And then that was B. Then you add C. You're going to go up, but just a little bit. You might notice in weather maps they have all these little arrows. C. So this is where you ended up. If you sail this way, then you sail that way really far, then a little bit up. The result is you started here, and now you're here. So the result is this. This red arrow is the resultant vector. So that's why I say here it is in my drawing. I tried to go like this, then down, then up, so my result's like this. Your drawing won't come out perfectly every time, but just draw it. And there's my resultant vector. What do we got next? Okay, so we got some information. Write the vector in terms of I and j. So we're going to go a magnitude of 200, like you're going to go 200 miles at 300 degrees. If you want to draw it, you can. 300 degrees, it's way over here. and you're going to go 200 miles, okay, in that direction of 300 degrees. So if you kind of look at it, I want to know, so how much did you go over and how much did you go down? What was your I and what was your J? I expect I to be positive and J to be negative. How do we do it? Super easy. Just punch them in. Magnitude's right here, 200. Put the cosine, remember cosine is the x. There's your angle, 300 degrees. And then you're going to throw an I on there. You're going to punch that in the calculator. Not yet. Sine of 300 degrees. And here's J. Close that guy up. So what are we going to do? We're going to distribute 200 times that and 200 times that. Now we punch it in the calculator. Let's see, we've got, how about if you want to put the cosine in first, if it's easier that way, you can. Cosine of 300. Okay, a half. Perfect number. Times 200 times 200. So 100. So you went over 100 miles. Okay, so you went over 100 I's. And then sine of 300, you can even look these up on your trick sheet. Sine of 300, negative radical 3 over 2, but you're doing 200 of those. If you left it, you'd have a unit vector. Times 200 of those, and it says negative 173. So I'm going to put, instead of plus, let's put minus 173J. I'm just going to round it off there, which makes sense. You went down 173. And this is your resultant vector. I'll get my little blob off of there. Make sense? Over 100, down that. So that's your resultant vector. So this is kind of like polar coordinates and rectangular coordinates. Kind of like the last chapter. Okay, number 10. I got a 10 again. You know why? Same question. You go 100 miles in a direction of 80. You want to draw it? Let's see, 80 is about here because there's 90. You go way over here. You travel 100 miles in your balloon. So how much did you go over and up? Looks like it went over a little bit and up a lot. So there's your magnitude, 100 miles. This gives you your X amount. This gives you your Y amount. In physics, this is huge. You're always going to find, like, how much did something move this way and that way? What are the forces? So put that in the calculator, times by 100. There's the X, or as we say, the I. And I did this guy, times by 100. That's the Y, or as we say, the J. So there's my resultant vector. Sounds right. Over 17, up 98.5. Okay, easy question. Work. Okay, so a sled is pulled 100 feet with the handle at 10 degrees. So I tried to say, okay, look, here's the ground. So you got this at 10 degrees. Here you are pulling with a force of 5 pounds. You know, don't want to work too hard there, right? Only pulling, you're going to go 100 feet. How much work did you do? Remember, work is the force times the distance, but we're at kind of an angle. Some of your force was actually pulling upward. You want to be efficient? Get the rope down as low as you can. So we just need this X component. So that's the cosine of the angle. So this is the formula. So the force, 5 pounds. The distance, 100 feet. But part of your 5 pounds of force is being wasted because you have a little bit upward. I mean, if you went straight upward, you wouldn't go anywhere. So the cosine of 10 degrees. Punch it all in the calculator. So 5 times 100 times cosine of 10. And, well, that's 500. 492. You were pretty efficient, weren't you? 492.4 foot pounds. That's how much work you did. It's kind of like you moved 492 pounds a foot, if you think about it. Kind of makes sense. You know, if you lifted a 10-pound weight 3 times, isn't it kind of like moving 30 pounds? Okay, this is the big question. This is the bonus question. This is the reality question. This is the AP physics question, considered like the hardest AP test of all. Okay, so I'm going to draw this out. So there's a boat. It's on a course of 100 degrees at a speed of 20 miles per hour. In fact, in an hour, it'd go 20 miles. However, the current is going to push you off course. Okay, so here's the current. I'm going to do it in red, is west, 180 degrees at 10 miles per hour. What you should do is add the vectors. Let's put these together. Let's say you tried to go this way, but the current is going this way, isn't it? 10 miles per hour, exactly 180 degrees. There's my graph paper. So if I draw it right on here, how far should I go? Well, if this is 20, 10 is half of it. So, you know, the current's not as strong as the speed of the boat. It goes 10. So I'm looking at that. Let's go about half of it. Now, see, if I were an actual navigator, I would be doing this out really perfect. I would have, you know, rulers, and I would have a protractor and all this stuff. But I would do it like on an actual map chart. So we'll go this way, 10 miles per hour. So what happens to the boat? You might say, hey, I'm going to go over here to this little island, and you head that way, but the current drifts you over here. So by the time you're getting there, what's actually happening is this is where you're kind of ending up, or speed-wise, this is the result, the resultant vector. So even though you got the speedometer set at 20 miles per hour and your course locked in, you end up going all the way over here. You actually go a little bit faster. The current's not directly behind you, giving you a push from directly in the back. You're not headed directly into it where it's slowing you down, but it's kind of sideways. It's giving you a little push and pushes you a little off course. It pushes you a little bit farther off course. So what you have to do is add the vectors. But you can't just add and say, well, 30 miles an hour? No. And you can't say, well, 280 degrees? You can't add the angles. 280 would be down here. That doesn't make sense. It's a little more than 100. How do you do it? Change these to I's and J's, then add them up. Okay, so I did like number 10. I took the boat. Remember we did number 10, the magnitude and the angles here, cosine and that. So I did 20 times the cosine. I got this, 20 times the sine. So just set it up like number 10. I got my vector, which makes sense. It kind of looks like you went back 3, up 19. Then did the water. The water's going this way. 10 was the magnitude, the speed of the water. Cosine of that, sine of that. I got negative 10 plus 0, which makes sense because, you know, it goes 10 this way, but not up. Now, you can add the vectors. Let's add these together. Let's plus them up. And so when you add them, negative and negative is negative 13.47. I use 2 decimals because I'm in the middle of the problem. I don't want to round if I'm not done with the problem. So I get negative and negative, negative 10, 13i, plus 19 and that is 19.7j. But I want you to change it back. You're not done yet. So you say, well, what's the speed and the direction? Wait, this doesn't tell me the speed. How do you change it back into a speed and an angle? Okay, so what you have to do is draw it out. You went back 13 this way and up 19. That's what this green guy is. Back 13 and up 9. So once again, there's the vector. Well, let's figure out how far did you travel? Wait, Pythagorean theorem. That squared, take the square root. Okay, so Pythagorean theorem, I put that on the calculator, I got 23.9. What is this? This is the distance. This is actually the speed, not distance, and this time the speed's 23.9 miles per hour. Makes sense, you're going 20, you got a little bit of a boost. So that's our speed, 23.9 miles per hour. And then the direction, what angle is this? Well, let's do the, well, maybe I should find this angle. What is the tangent? What's the opposite over the adjacent? Let's put that in the calculator. Let's go second tangent of opposite over the adjacent. Now, will my calculator give me the correct quadrant? So you got to be careful of that. It's something we kind of briefed over a little bit because of our time. We did in a previous chapter. Because remember the calculator? There could be multiple answers. Remember like tangent, like say you were trying to get 1, but there it is again. Which one is it? And tangent keeps repeating every 180 degrees. So let's punch it in and see what we get. Okay, so I put in second tangent, that, divided by negative 13.47. I'm gonna hit equals, and it says negative 55 degrees. Okay, at this point, let's round it off to negative 56, negative 56 degrees. Negative 56 degrees. But does that make sense? What is negative 56 degrees? You gotta have the drawing. That's why it's AP Physics. Negative 56. negative 56, let's use a new color here. Negative 56 is this way, about right here. That's negative 56 degrees. Is that the direction you went? No, you went the opposite. So let's add 180 to this to make it make sense, because there is, it doesn't know which one. These have the exact same answer, just like, remember, sometimes you got some of the same answers. If the calculator just tried to find the closest angle to 0, it says, well, I got one right here, but I wanted that one. So let's add 180 to it. So I'm going to take that, add 180, because I want to be on the opposite direction. 124, and we had rounded off, 124. So 124 is my answer. Get that one out there. So 124, which that makes sense, 124. And that is my direction. Okay, so that's a bonus question. If we were in class, we would practice more time with that, but there you go, AP Physics. See how smart you are? All right, so practice all this, and then you got the test. You can do the test Thursday or Friday. So our last of the trig.